I hate this. It happened 3 times today morning. And I don't know when it will get a stop. Okay. So let's hope nothing dangerous will happen to me. And if it happens, it's recorded, and I will have a very dramatic moment. Okay. Okay, this is our lecture 8. In this lesson, we would first talk about Qt GUI, meta objects, compilers, signals, and studs. Qt, I will show you a Qt project, and then I thought I received some emails from some of you about how to install Qt on your PCs. I will also answer those questions. Then the last topic that we will discuss about is threads, and we will first discuss about data arrays, then mutex, atomic, and condition variables. I also added the serialization to your slide, but I'm not going to teach you, so you can study it yourself. I only taught this one in the first year that we gave this course. So, but we decided to eliminate this part from your course because I think you have enough to learn.
I'm sorry, we only see your Teams window and not the slides.
Okay. Share screen. How about now?
Yes, now it's okay.
Okay, very good. Okay, I showed you this slide. I said that we are going to talk about Qt GUI and threads, and the last thing that you see here is serialization and deserialization, but you can study that yourself. So the first thing is Qt GUI. What is Qt? First of all, it's really good to know that it's pronounced as Qt. I heard from some other people that they pronounce it as Qt, but it's not. It's in its documentation. It's written that it's pronounced as Qt because the second one, I mean, the T is written in a smaller case. I mean, it's not uppercase. And it's a cross-platform application framework. It's easy to learn. It has a comprehensive documentation with good examples. You can go to this address and you will see a large amount of many different examples. We will show you some of these examples here in this lesson, but you can learn it yourself. It's not really difficult to work with, but it's really important to implement everything in an efficient way. So it's not just, yeah, you can implement your program in just one file, as I saw from your first projects, but this is not efficient. So when you are learning a documentation, you should always keep in your mind that I should write my program in an efficient way, and I should be really optimized about what we are going to implement. So what does it mean if we say it's a cross-platform application? It means that it can be run in different operating systems. For example, if you implement a program in C++ or Python, you can run it in in different operating systems. If you also follow everything. I mean, for example, if you use boost path or steady path, because we know that we have different paths in different operating systems. So you won't have any problem if a library is cross-platform, if a language is cross-platform. So Qt is also cross-platform. But for example, we have a language named Swift. It's only used for iOS devices. I will kill them. Okay, and I was saying that we have Swift. It's only used in iOS devices, and then we also have, for example, C#, which is only for Windows. So, but in this course, we try to write a program even if you use only Windows, because Visual Studio is designed for Windows. But your application, if you your exe file can be run in different operating systems. So we try to be like that. And Qt is also cross-platform. Qt GUI, graphical user interface by which users interact with a machine. So I guess you already have experience. I'm not sure, but I guess you have experience. I mean, at least you're working with, when you are working with different operating systems through their GUI, not from the command line. You saw that we have, you work with some windows, and those windows are the GUI that you are interacting with the program, through which you are interacting with the program. So Qt GUI is also a way that let the user interact with a machine. And you are all, I mean, in the last lecture that we had, I also showed you how you can create a Qt project. I know some of you have some problem with that, and we will discuss about that in a couple of minutes. And but I told you that we have 4 different files. .ui, which is an XML file containing physical widgets. We use Qt Designer to design UI. So we are not going to work with XML files directly. We open them in Qt Designer. It's a great help for us. And we add our widgets using that designer. We design our widget using that Qt Designer. There is another file, UI underline, the name of, I mean, the same as, the name is the same as this one, the name that exists here. This is the C++ file generated from .ui file. So it will be generated automatically, and we're not going to change it at all. Even if you change it, I mean, in the next compilation of your program, it will be changed. So if you cannot change this one, you can change it, but if your change will not be considered. The other 2 files are a .h file and a .cpp file. You are already familiar with this 2 files. These 2 files is a header file for logical components, and that CPP file for the source file for your logical components. And when we were reading your projects, we saw that some people only use .h file. I strongly suggest you to go to previous lectures, watch the videos, or read the slides. You will see that we told you that the .h file are a location in which we put our declarations, and .cpp file is a location in which we put our definition. We can have a library which is header only, so it means that everything is written in a .h file, but the purpose is different. So you're not going to implement such a library. I mean, especially for your first project, it was a console application. So you were not supposed to do that, and don't do that for your next project. And for your next project, you're going to have a DLL, and again, that library is not a header-only library. So you will have some header files, some CPP files, some interfaces. And if you cannot remember, just go to the last lecture that we had, and you will learn how to write a DLL file. We will see one example also today, and you will see how I interact with the library and how I implemented a Qt project. Is it going to stop? If it is continuous like that, I have to have a makeup session for you. Otherwise, we cannot teach like that. Oof. Okay, I mute myself and see when if it is a stop, I will continue teaching. Okay, it just stops. So I was saying that we have a .h file. This is actually the last lecture that we have, and the next lesson we will only talk about your projects and your questions. And but it's good if it continues like that, and I will be distracted many times. We can have the next lesson for this lecture. I guess everyone should sleep at this time. I don't know what they are doing now. Okay, so when we have a class, when we have a Qt class, that Qt class has a structure something similar to this one. We have why? Okay, the meta object compiler. Okay, in Qt project, we have a meta object compiler, the program that handles Qt C++ extension. So we know that we have a compiler in C++ that will translate our program into a machine language. So we write our program in C++, but it will be converted to the machine language using the compiler. For Qt, we have a meta object compiler, which does the translation between the Qt commands to the machine commands. So mock is typically, we call this one mock. Mock is typically used with an input file containing class declaration like this. So every Qt class is inheriting from an object, which is Q object. And it has a macro, which is Q underline object. Using this macro, we say to the compiler that this is the compiler should translate this class, and this is a Qt class. And this class, as we said, it's inheriting from a Q object, and also it has an input in its constructor as this one. Its default value is 0. as it has a destructor, it has some signals and some slots. And it can have many different signals. It can have public and private and protected as other classes that we have in C++. Also, the slots can be public, private, or protected. So this is also the case with signals. But here I only wrote public for you. In the examples, you will see that I will put them as private. So what are the signals and the slots? The signals and the slots mechanism is a way that the widgets communicate with each other. So it's similar. I don't know if you have any experience with implementing a GUI. You know that, for example, we click on a button, and when we click on that button, a function will be run. And this is here is like that. When we click on a button, a signal will be emitted, and that signal is connected to a slot. And then, since that signal is emitted, that slot will be run. Signals also can be connected to each other. So when a signal is emitted, it can, since it is connected to multiple signals, those signals will also be emitted. So, but the common way is like that. We have a signal which is connected to a slot, and when that signal is emitted, that slot will be run. So we have here signals and slots mechanism, which is a central feature of Qt, and probably the part that differs most from the features provided by other frameworks. As I said, in other frameworks, you have underline click something. So you have some functions like this. If, for example, in what do we call that? NFC or something like that. In C++, you have a way that you can, I cannot remember the term, I think it was NFC or something like that, that you can implement your Windows program, but it will be only useful for Windows operating system. And there you have some functions that are connected to to your objects, to your labels, to your class, to your buttons, and so on. But here you have signals and slots. You have also some slots that are already predefined, and they are already connected to the signals, and you can also use them. But mostly we will have two different things, signals and slots, and we connect them, and then the program will be run. So a signal is emitted when a particular event occurs. A slot is a function that is called in response to a particular signal. Qt widgets have many predefined signals and slots, as I just said, but we can always subclass widgets to add our own signals and slots to them. So if you see from your project definition, I said there one of the features that I said that you can add to your project, it's not compulsory, but you can add, is that, for example, you have a text box and you can inherit from that text box and add some other signals and slots to that. And if you do that, you will have a new text box, which is a custom text box for you, and you implement it yourself. So you can do something like this in your project, but it should have some purpose, and you cannot just do it for nothing just because you wanted to have a new feature. No, you should be able to convince others that you really need this, you really want to have this, and there is a application, there is a purpose for having this one. There are different ways to connect a signal, two different ways, string-based connections and functor-based connections. When Qt has been released for the first time, we only had string-based connections, but from the Qt 5, we have also functor-based connections. Both of them have some advantages and disadvantages. And the first one is this one. You have a function in Qt, which is whose name is connect. And to connect a signal to a slot, we write here the first argument of connect is sender, which is the object that sends, that emits that signal. And then we have a signal like this. This is the signal. It doesn't have any body. It's just like when we write a declaration for our functions, it has just this one. And it has two arguments here, but it's not always like this. You can have multiple arguments like other functions that you write. But don't confuse signals with functions, because signals are just some declaration. They don't have any definition. But we have some arguments here and a name for that. So in this example, the name of the signal is value change, and the arguments are QStrings. We have two QString arguments. We don't write the name of the variables here. We just write the type of the variable. Then the third argument of the connect is receiver. Then the fourth one is the slot. So the receiver is the object that receives this signal and has to run this slot. So when we connect the signal of this sender to the slot of this receiver, it means that when the signal of the sender will be emitted, this slot of the receiver will be run. The slot of the receiver has only one QString. So in when we are connecting these two with each other, they should have similar number of arguments, or the slot can have lesser argument than this one. The type should be similar as well. We can also disconnect these two using this command. So as you can see, this is similar to this, but the only difference is disconnect. These two are just two macros that are defined in Qt library, and using which we can define, we can say that this is a signal and this is a slot. How about functor-based connections? In functor-based connection, we have connect again, but the way that we connect here, we don't use these macros, but we have ampersand, the name of the class, and the name of the signal. We don't write these parts also here. We just write the name of the signal and the name of the slot. But the good thing here we have to connect signal to another signal or to another slot. We cannot connect this one to a regular function, but here we can. Here we can, it's not compulsory to be a slot. It can be a Lambda function. It can be a regular function. So this is the first difference between these two. I mean, the first difference was that they have different syntax. The second one is that we don't need to write this part. We can't write the arguments here. And we will see some other differences later on. And for disconnect, it's again similar to connect, but the name of the function is different. So what does this one do? If these two are connected to each other, this will be disconnect. I mean, also this is the case with this syntax. But what does it mean? It means that if the signal of the sender will be emitted, the receiver will not respond to that signal. It is useful when you are updating your window and you during the update. So for example, you have a value change and you are updating, but you don't want to this slot will be called if you are changing that, because you are changing that logically in your program. The user, I mean, you usually write these to interact with your user, but you are changing the value inside your application. So in some cases, you may not want that the slot will be run when you are changing that. So in that case, you can disconnect that for the moment, and after you change your value, you change your widget, you change your sender, I mean, and then after that, you will connect it again. So this is the one use case for in which you will use disconnect, but it's not really common. So you don't have, it's not like deleting pointers that you have to disconnect everything that you connected in your program at the end. No, you don't have to do that. I mean, in rare scenarios, you may need to do that. You may need to use that. So you can go to this address to see some examples for these advantages and disadvantages that I'm going to share with you for these connections, string-based and functor-based. But we will see some important example. I mean, I will tell you all the differences, but we will see some examples of the important ones. But to see more, you can go to this address to find more examples. So one of the differences between string-based connections and functor-based connection is that the type checking is done at runtime for string-based and at compile time for functor-based. What does it mean? So if, for example, here, if the type is not similar, because we said that here the type should be similar, but if the type is not similar to each other, for the string base, the error will, we cannot see the error when we build our program. We only see the error in the runtime when we run our program. But for functor base, you will get an error if that happens. I mean, if the type is not similar, the types are not the same in your compile time. So when you build your program, you will see the error. So in this case, we can say that this is functor base is better than string base for these applications. Functor base can perform implicit type conversion. What does it mean? So it's if we have, for example, in our signal, we have a value of type double. In our slot, we have an argument of type int. In this one, we cannot have type conversion. We will have an error in the runtime. But for this one, we will have implicit type conversion, and so the connection will be made. We will see one example of this in the next slide. Functor base can connect signals to Lambda expression. As I said in this, I mean here, I told you we can. Here we have to have a slot. But for this one, this can be a Lambda function. It doesn't have to be a slot. You are familiar with Lambda expression. If you cannot remember, just go to the previous expression when we are discussing about standard template library. There, I gave you some examples of Lambda functions. You can also use that for example, copy for find it. But here you can also use those Lambda function for your connect function here. String-based connection can connect signals to the slots which have more arguments than the signal using default parameters. This is some examples of this one, and you can understand that better. But with this one, we cannot have this. String-based connection can connect C++ function to QML function. In this course, we're not going to discuss about QML functions, but if you are interested, you can study yourself. These are another way that you can create your GUI with more features, but in this course, we're not going to discuss about that. So we said that we have implicit type conversion if we have a functor-based connection. So let's see here. We have QSlider is a this example is taken from the previous address from this address. This is just a cute widget. Or we can call it a cute widget or a cute object. And with new, you're already familiar with that. We know that we are getting a location from the heap memory. In your first, when you were presenting your project, your first project, I saw some people really don't know the difference between here, the difference between stack memory and heap memory. And I saw that you're using pointers in a stack memory. And I think for those people, it's really important. I gave you already the feedbacks, but I'm again repeating my voice to remind you should study those parts if you cannot remember these things. And so we are a QSlider. It's an object. We create that. We put it in a slider, in a variable. It will be of type. A slider would be a pointer of type QSlider, and we have also a Q double spin box, and it's also we have a pointer of type that. Now we are going to connect value change, the signal named value change of QSlider. It's a predefined signal for QSlider, but it's not connected to the slot of this Q double spin box. Q double spin box also has a predefined slot, which is set value. So we can connect value change, the signal value change of the slider, QSlider, to the set value. So with this one, this is okay, we can have it. But with these two, since the value change gets an argument of type int, but the set value gets an argument of type double, and as you can see, we write it here, this connection will not be made because we do not have implicit type conversion for our string-based connection. But we won't see that this error, we see the error in runtime. And I think connect returns a Boolean function, and you have to check that Boolean function to see if the connection is made or not. The connection was successfully made or not. So this is one of the difference between the string-based connections and functor-based connections. Another difference, we said that here imagine we have Q application. We will see, you already probably seen that we have a Q application. Then we create a QTGUI project. In the main window, we have you will see that an object of type Q application will be created, and there you have that object has an function, has a slot about to quit, about to quit, and so that this slot does not take any arguments. It's a signal. It's a signal which does not take any arguments. We have also some slots here. We implement this slot for ourselves. So we can connect a signal to a predefined slot or to a custom signal or to a custom slot. So here also we define a slot, and that slot has a an argument, and that argument has a default value. So with this way of connections, we can connect these about to quit to these slots. And we don't write anything here. This one doesn't have any argument. This one has an argument, but it has a default value for that. So we don't have to write it. And if we don't write it, then we can connect it to a signal which does not have any arguments. So this connection will be successfully made. And but this cannot be happened with the functor-based, because we don't write anything here, but it expects to have the same number of arguments for both of them. So it cannot be successfully made. But how can we solve this? We can write a lambda function here, and inside that lambda function, we can call these slots. So this is a trick that we can connect a signal to a slot which has a default argument. If you want, you can go to that address, then you will see also some examples about that one. But the other thing that is very useful in Qt is QSignal Mapper. QSignal Mapper is a Qt class which lets you to connect many signals to one slot, to the same slot. But that slot needs to handle each signal differently. So this is a use case that may happen to you during your program. For example, you have you will use right click and you will open a menu for that. You have that menu, for example, shows different names, different file names, and you are supposed to read each file name. If the depending, a file name depending on the file name that the user chooses. So the body is again the same, but the input is different. So in that case, so we will have different signals emitting from different objects, but we are going to connect it to the same slot, but with different input value, with different inputs, because the name of the files is different. So in that case, we have, for example, 3 different buttons here, okay? And all of them has a clicked signal. So we are going to connect the clicks of this one to a slot which read a file, and if I click, for example, text file button, then I want to read text file.txt. If I click on this button, I want to read account file.txt. And if I click this one, report file.txt, using this slot. So the slot is the same, the body of the slot is the same, but the input of the slot is different. So how can we do this? How can we deal with this scenario? We can define a QSignal mapper here. The simplest way is that we will have different slots for each of these things, and we will connect each of them to this slot. So we will have 3 different connections for 3 different buttons. Okay, for this scenario, because we only have 3 buttons, you may think that, okay, we will have 3 different lines of code and we can use that one. Why we should have a signal mapper? But this is not always the case. You may have many different buttons, and so it's better to use signal mapper. So the advanced way is this one. We first create a QSignal mapper, and then this signal mapper has a function of whose name is set mapping. It receives an object and it maps this object to another object. We write it here a QString. It can be an integer value or any other thing. But for us, we wanted to have it as a QString. Also, we do this for the other objects. Then we will connect the clicked signal of this button to the slot map of the signal mapper. So I will do the same for the other objects. So account file button clicked signal mapper mapped. What will happen if I click on this button? The slot of the map slot of the signal mapper will be called. But what does this map do? This map will emit the mapped signal of the signal mapper. Okay, so now when I connect this clicks to mapper slots, then I will connect the signal, the mapped signal of the signal mapper to a slot of read file QString. So in this case, when I click on this button, at the end you will see that this one will be called with this value. But it's similar that we have to go through something to reach this point. This example is also taken from Qt, but we will see some example also in our project now. The last topic that we are going to discuss is threads. But first, let's see how can we add, how can we design a Qt window, and then we'll come back to threads, and inside that, and then we again come back to our example to see how can we use those threads. Can you see my Visual Studio?
Yes, we can.
Okay. So this is the project that we created in the last lecture. I'm not asking you if you get what I said till here, and that's the reason is that I want to first explain these things to you. Then I think your questions, your potential questions will be resolved by explaining these things. So I mean, if you follow the screenshot that I provided to you in the previous lecture, you will create a main window. I mean, you will have a main window.ui in your form file. But I also changed this main window, but we are going to create it now again ourselves. So I'm going to use Qt Designer. I can use other things, but I'm going to use Qt Designer to open this main underline window.ui. So it will be opened here, but I prefer to detach that and see it in the Qt Designer, and I will open it here. But before that, let's see. Let's go to this address. Okay, this is main window.ui. If you open that, you will see this is just an XML file we're not going to change this one at all. This will be generated by the Qt designer, okay? If you change something here, you will see the change also here. But, you know, it's very prone to error if you change something here. For example, you see here width and height 600, 400. You will see this one also here, the geometry 600, 400. So the Qt designer is reading this file and try to visualize that for you. And you can also add some items here. So we're not going to work with this one. We only work with this. But let's also see some other things. You see here, this is generated, but since I built this code, you can already see this file. So what's inside this? This file is generated, as you can see, from form generated from reading UI file, this one. So it is generated automatically. Again, we're not going to change anything here. Okay, this is UI underline main window. That if you build your program, you will see that. And as you can see, we have Q widget, central widget. Let's see. Oh, okay, here. This is what we saw here. So QXML file. Oh, sorry. This file is not a C++ program. So the compiler will convert this file to this C++ file for us. And it will be generated automatically when we are not going to change anything. But what we have here is main window.h and main window.cpp. What we change, we open this one in Qt Designer, we change it here. And we have main window.h and main window.cpp, and we update this one. We add our slots here, we add our members here, like other classes that we write in C++. And the declarations are here, and the definitions are here. Okay, you see here, this is the definition for this one, for these slots. And we saw this slot here. So I really expect you not to, because I'm repeating my words, because I saw some codes that we only had one file, or we only had header file. So don't do that. Let's create this UI again here. Main window, because I want to have a main window, I can create a widget, and then if I create a widget, I should use that widget inside a main window or inside another widget. I can have dialog widgets and so on. But this one is a main window, and you will also work with main window. But if you want to continue work with Qt, you should also learn these things. But for us, it's okay. We will only work with main window. I press create. This one is not saved anywhere, and I'm not going to save it because I already have this. But for you, you should save it. So I know this is 600 and 400. I can also go here and change this one to 600 and 400. Okay, so the size of this one is now 600 and 400. And now it's not. So it's 600 and 500. But we cannot, what we have here, this is the first object that I have. Its name is command line button browse. From this naming convention, I know that it's of type command line button and the name is browse. These names are really important because in your .h, main window.h and main window.cpp, you will work with these names. You can see the names here. I think we also see push button second window. I can see browse here, but probably is connected to this one. Push button. We will search it later, but okay, for the other one, for example, this one, you can see it's push button second window, and I have also push button second window. Not here, push button second window. So the names are really important because you are going to work with that in your .h and .cpp, and you should know from the name what's the type of this widget, and you know that from this one it's push button. So if you add, for example, now I want to add this one, command line, command link button. I add it here, and I can see a command link button. I only add my name to the end, and I wrote the name and pressed enter. To change the name of this one, you can go here to title and change this one, browse. And so this, the other thing that you will see here is this button and this button and one label here and something, I mean, we call that a spacer between these things. So first, let's add this one. Again, the type is push button. You can also see here the Qt designer is showing to you that it's type Qt push button. There is Qt push button. Qt push button is here. I changed the name to second window and name to second window. Let's see the size of this one. The size of this is 8423. Let's change also this one. I mean, it's not compulsory to be like that. I'm just trying to mimic this one here to show you how can you create, I mean, to make you familiar with these widgets and how can you work with them. Okay, I didn't write any space here. And 86. And the other one is show ID, push button. And I write the name to show ID. Oh. And the size was 86. And we have one horizontal spacer. You will see the effect of horizontal spaces when we use some layers here. And we are going to add one label. And that label has name of ID. And it only has one dash as its argument, and the size is 4. Just to 4. We have one table view here, and there is the table view. We have table widgets and table view, and I strongly suggest you to use these views than this one, because these are easier to be used, but these are more effective. I mean, for example, you may start with this one, and after a while you will see that, okay, I have some problems, and then I have to change and go to this one. So I strongly suggest you to use the view forms. These are model-based, not item-based. We will see some examples today of them. And table view, we put it here. And also, what is this one? Text browser. We have text browser here. And let's see the name, file content. I call see this one here. I mean, you can just write it. And the table view name is file list. So as you can see, if I put my mouse here, you will see it has a splitter. So I can change the size of these two when I run the program, not now. I mean, not if I try now with dragging my mouse, I can move it. And but this is useful when you run your program. You want to change the size of your, as you can see, for example, in Qt Designer, you see this is the effect of Qt Splitter. If I do this one, I can change size of this widget and also size of this widget. So we are going to have something similar to this one, but you saw here for our widgets. We have two widgets here, and we want to change the size of them with this thing. To do so, we select both of them, and then I will use this one. What was that? Okay, I press Ctrl Z. If I put my mouse here, it says that layout horizontally in a splitter. I can also do it by right-clicking layout horizontally, or no, sorry, this one is layout in a splitter and horizontally, should be horizontal. So now it doesn't show you anything, but if I save this file and open it again, I will see this, my mouse would be, my mouse pointer will be changed. But again, I cannot change it until I run my program. So now, what you can see here, you see that these are in a layout horizontally. So we want to put these label and this one and this one and this one in a horizontal layout. So I can use this one or either right click here and layout horizontally. So as you can see, these will be in a layout horizontally with this one. Now, as you can see, these are in, you can also see here, this will show you your layouts, your objects. So if I click this one, this is the splitter, and these are in a grid layout. So these are in a grid layout. You can see the layout with these red rectangular, red lines. And then we have a central widget. Okay, let's create a grid layout. We click here in between to choose this layout, and then here to choose to select this splitter, and then I click this one to choose this. So as you can see, these are selected now. Okay, now I want to create them in a layout. So layout in a grid. So as you can see, we reached to this point. Okay, now this is not really good. It's here. I want to fit it to my window. What can I do? Right click, layout, and then layout in the grid. Okay, it became really worse. This is growing, the size of this one is growing, this one like that, and these are fixed. But in this example, we prefer to have larger text view than these two. So then what we should do, we just select our splitter. You can also change the name of your splitter, but since in this window I only have one splitter, I didn't set any name. I'm not going to work with the splitter in my .h file, but you can also do that. You can also set a name. So with this one, as you can see, we have horizontal policy and vertical policy. The vertical policy is preferred. We can all have different one, minimum, maximum, preferred, minimum, expanding. I'm going to put it expanding. So it means that if, the policy of this one is expanding. So, sorry. So we are going to, if this, we have blank space, then this will be expanded and fill those blank spaces as we had previously. This one, as you see, the effect of this one was that if we had that blank space, when we, I mean, this will grow. So then it will, when it's grow, you cannot see that when you run your program, but it will help you to keep this label in the right side and keep this button in the left side. So these are tricks that help you. These are the widgets that help you to design a flexible UI. So if I maximize this window, or if I change the size of this window, look at this. If I change this, my window will not be ruined. Let's see this one, for example. If I change the size, as you can see, this is not really interesting. We are not going to look at my designer. You see the designer, this window is designed correctly. So you see here, the size of this one is changing. You see? So your application, your GUI also should be like this. You should not have something like this. I mean, it's very ugly. So this is how you can work with your GUI. And let me also lay out in a grid, and this was expanding. It has changed again. I have to make it expanding. So this is the way that you should implement your program. You should use these layouts. You should use these spacers. You should use these splitters to make your program more interactive, more desirable to your user. I don't like to see, for example, I mean, it's okay, you can change the color of your programs or and so on, but I saw some people from last year that they changed the color of their programs, the font of their widgets. We don't need these things. We just want to have an UI like this one, like Qt Designer, that is really easy to work with. It will not be ruined. If I maximize this one, as you can see, it will be, this part is always in the left, this part is always on the right, this one is always at the top. So it should be like this. So I'm not going to save this one. Let's see how can we work with this one in our .h and our .cpp. But did you get till here? How can you work with Qt Designer?
Yes.
Okay, if you have any question, you can ask. No? Okay. Okay, I will close this one. I'm not saving because I already have this one, so I discard this. And I will close this one. I changed it, but I don't want to change it, so I discard the change. Something that I should tell you. If you change something here, you won't see, for example, if I add a button, okay. If I add a button here, if I add a button to this one, until the moment you will build your program, you won't see that button in your .h and your .ui. Why? Because only if, I mean, when you change something in your designer, this file will be changed. But to work with that object, for example, with this browse button, you should have it in this file, because the .h and .cpp file only see this one. So you have to build your program to see the changes that are made here, and also here. Okay? So, for example, don't panic when you add, for example, something here and you see that, okay, I cannot, I add some button, but I cannot work with them. You have to build your program to see that button. Sometimes even because these are two different applications. We have Visual Studio, it's an ID, we have a designer. Sometimes even it may not be seen by the Visual Studio. Then you have to close your Visual Studio and open it again. But it's very rare, but it may happen. Okay, let's close this one. Let's go to main window.h. So we saw that we have our Qt object has a class like this one, Q main window, and it's this one. Since it's a main window, it's inheriting from main window. If we go to the definition of this one, go to definition. You can also press F12. You see that this one is inheriting from Q widget. Okay, so if this cannot be open, I guess, yeah, because it's inside the library. But these are the codes that is written in qmain-window.h. So you added this one. When you create this file, I mean this main window.ui, as you saw from the previous lecture, I mean you have .ui, .h, UI underline.h, and .cpp, and there it will generate this one for you. If it's in some Qt version, it may not generate, but you know this. You should learn this so you can write it yourself. You can also, I mean, these are, you can see that this is included, and that's why we can see the objects UI underline main window.h. As I said, this is the file, the C++ file that is automatically generated from our .ui file. So I need to see this change here, any change that you made through this file. This will give us an object which is UI. I have here. In the previous version, it was a pointer, but here it's, I mean, in the version 12 that I'm using, it's not a pointer, it's just a local function. You can also create a pointer, but don't do that. I mean, we prefer to avoid pointers as well, if we can. I mean, it's not really good to avoid pointers for all the time, but in some cases, like here, we can. So we have some signals and we have some slots. Let's see one of them. So this is the predefined slot. It's already connected to the clicked signal of push button show ID. What was push button show ID? Let's open it again and see the push button show ID. Show ID was this one. This has a predefined slot, and we have it here. We just write this one here on underline name of that button, underline clicked, and parentheses equals that. But we should define it. Where is the definition? The definition is here in our main.cpp. So we are writing the logical part behind this widget. Inside this, I'm creating an object of type human from my library. I think I gave you this example in the last lecture. And then, but it was inside the slides. So I use this method and I get one object of type human, which is an interface. And I save a shared PTR of that. And then I update label ID. What was label ID? This is label ID, okay? And I use the method of label ID, which is setText, and use the method of getID, which is the getter method of our human objects. And I use again QString from QString, a function from a std_string, because getID is returning, as you can see, const std_string. It's returning const std_string. So then I convert it to QString because setText requires a QString. So in Qt, we have QString, but in C++, in a standard template library, we have a stdstring. But there are some functions to convert them to each other in Qt, and it is really good to know. You can also have, for example, QString from number. I think it's number. Yeah. For example, this one expects a double value and returns a string. So sometimes you want to show a number in your label ID. In that case, you have to use this function. Just to remind you what was this structure, let's go to definition of this one. I press F12 and I press Ctrl-Alt-Home to keep this one open. And this is the ihuman.cpp. This is my ihuman.cpp, which I have here, okay? I had also ihuman, I have human, also ihuman. Let's go to definition of this one. Ctrl-Alt-Home. And I explained this one in the previous lecture to you. We saw that we have a human.h class. We implement everything here. We have human.cpp. We implement the definition of that here. We should have some other things, just some example. And I have ihuman.h, which is an interface for my human, because I don't want to export human.h with my GUI. I don't want to let the store GUI to see how I implemented human.cpp. I don't want to let him to see that. So because of that, I have ihuman.h. Inside that, I have this one, which is an interface, which has only pure virtual functions, but it has also not this class, this namespace, this library has a function. It's in this namespace, it's not in the scope of the interface, which is just a function, returns an object of type human, but inside that get human, we saw that we knew an object of type human, converted to ihuman and return it. So GUI will see ihuman, but in fact, inside that there is human. So it will not be able to convert it to human because we don't share human.h and human.cpp with our store GUI. As you can see here, just repeating what I already taught to you. So as you can see here, I only shared this path, the ext store include. So it only sees store GUI, it only sees the files inside this path. Let's see what's inside this path. Inside this path, ext store include. So inside this path, the only thing that exists is I_human.h. So it will not see, a store GUI will not see these three files. Okay? So that's the way that we share our code with this one, with our store GUI. So again, although both of them are in the same project, this is just to make it easy for you. But in fact, you can just you can have any other project here and connect that project to store. So you can always keep in your mind that this library needs to be used by many different libraries, even libraries or different projects, different GUI or console applications. So you should not try. These two should be really independent from each other. So in main window, I use getHuman to create an instance of iHuman. Then I will work with getID. GetID is the pure virtual function that I have here. So if I have other functions in human.age, as you can see, we have set height. But in iHuman, I didn't write a pure virtual function for set height. So because of that, if I try here, the only thing that I see is getID. I cannot see setID because human is of type iHuman, even if it's inside that we have human. StoreGUI doesn't see that. This shows that how can you encapsulate your project. Encapsulation should be done in different levels. It should be done in the level of classes. It should be done in the level of your functions. It should be done in the level of your projects as well. So this is that. I also gave you an example. How can you work, for example, I don't know if in this example I have this or not. I guess I don't. But you can also feed this one. For example, you can have your iHuman can have a function here. I mean, you may have another class that expects to work with, for example, you have a filter class, and that filter class expects human objects. Okay? In that case, StoreGUI will pass iHuman to your DLL, to your library, but inside that library, you know that it was human, so you will use dynamic casting to convert it to human, and then you will work with human from that time onward. I think I already gave you this example in the previous lecture. You can also go with that. But what is the usage of this one for your final project? In your final project, you will have, for example, you will have a UI. Inside that, you will load a location of memory, some files and from folders and subfolders. You will create some objects. We call that human, data packages, anything. Okay? And then you will write a command, which is your select command in your UI. Then you want to pass, when the user asks you to run that command, which is the select command, you have to pass your human objects, which is created in your list of human objects, which is created in your UI. In that case, you have, for example, a select command or filter command, I don't know what you will call that, in your library. That select command will expect a list of humans. But what it will have, for example, here we will have a filter.h, and that filter.h has a function, has a class, that class has a function, and that function has an argument, which is a list of or a vector of any container that you define. This depends on your design of iHumans. But we know that the GUI created those iHumans using that getHumans. We, in our library, implemented getHuman. And inside that, we created human. I mean, so when we are in the function, in the filter class, which receives list of iHuman, we know that even if they are iHuman, inside them, there is a human object. So we can use dynamic casting to convert iHuman to human inside that library, inside that function. Then from that time onward, we can work with humans. Why we need to change that? Because then we can also work with the functions that iHuman doesn't have an interface for. So if I change iHuman to human in the library, I can now work with, for example, set height. I can see the other items of human. Otherwise, iHuman doesn't have anything. It only has get ID and a destructor. So if it's confusing to you, listen to this explanation that I told you several times, and also go back to your lectures. You will see, you will understand that. Okay, so I just repeat what I already said. So just wanted to remind you, because we also had some vacations in this time, so maybe you forgot that. So, but let's see, for example, here I define a new signal. This is a signal that I defined for this class. But this one is not a good example because we are not familiar with threads, and I don't think we have time to cover threads. If I start threads now, we will have to stop it in the middle, and it would be confusing to you. What I can say in the meantime, let's see, on command button click. Okay, these are all related to threads. Okay, but I think we have to say something about threads and then come back. Maybe not all of them, but some of them. Okay, so we will go to threads. In the constructor of main window, we have UI.setupUI. You have this object, you just saw that here. Okay, in the constructor, we call this one, and this one is implemented in UI_main window.h, the function that the file that we are not going to change that. And we can also create some objects inside our main window.cpp. So these are new objects that you will see in when you run your program. And usually we connect our slots in the constructor. So let's go to threads. Maybe we cannot cover all the topics, but I will try to say till the time that we have something to say. I mean, it will not be confusing to you. So what are threads? We'll come back again to the QGUI when we learn about threads, because if I try to explain the other things that we saw in the examples, you will see some threads and you will it will be ambiguous to you. So because of that, I first explain threads to you, and then we will come back and see the examples that combine threads and QGUI. In this course, we're not going to work with threads very much. So we will only use threads for our GUI when we really need that. So then you will for sure need threads, but try to implement your threads correctly. What is a thread? A thread is a single sequence stream within a process. So we have a process. Till now, we only had one process. We didn't have any threads. We had only main thread, and we only work with that thread. So everything has been run in a linear way. So we didn't have any parallelism in your program. But from now onward, when you are working with your GUI, you may need that. You may, for example, want to load something in your load some folders and subfolders, and at the same time you want to update your GUI. loading things should be done in a thread, and then the updating the GUI should be done in your main thread. So you will have a worker thread and a main thread. So a thread is a single sequence string within a process. You can have multiple threads. Your CPU has some cores. Every core can have 2 threads. So if your CPU has, for example, 9 cores, you can have 18 threads. I mean, maximum number of threads that you can have here for your CPU would be 18. It depends on the number of cores that your CPU offers to you. So every process can have at maximum can have 18. I mean, it's not the case for all of them. Again, it depends on your CPU. But the threads can be run in parallel. A void thread to make a task run parallel to another task, to take full advantage of CPU power and reduce response time, to serve multiple clients at the same time. For example, you have a server client application, and multiple clients are working with the server. So the server has to respond all of them. It cannot say to the client, for example, we have 1,000 clients, and we say to the clients to 1,000, okay, let's first, I mean, it cannot be an FIFO, and we cannot have a queue of the threads. We may have, but as long as we have enough threads, we use those threads to respond those clients at the same time. So what is a thread? Let's see one example of the threads, and then you will understand. I use here boost thread. You can also use std thread. They are very similar. The only thing that you need to change is here you change boost to std. So we have one object of type boost thread. This one is a member function, member variable for our main window, for example. And this object receives a function. This is the function, the name of the function with ampersand. And this method, the pointer to this class, since this object is created for this class, and this class is, a variable, these lines of code is implemented again in this class. Since because of these reasons, we are sending this this pointer here. Otherwise, it should, if it is another class, then we have to send a pointer to that object. And the input values of load file list. So this is the input to this function. What does this function is doing? Again, it's receiving a text file, a QS string list. It's a list of QS strings. And then first, I set mtable model. Mtable model is a model. Let's go to the example. I think then you can see load file list. Okay, just some tricks. You can press Control and comma and write load file list to find that. Okay. The other thing in your GUI you can do, you are here, and you can find your function using this. Okay, so this is the thing that you just saw in your in a slide. And then this is the function that you can see that is supposed to read a list of files. Okay, but let's see if first this function and then come to this thread. So this is command link button browse. This is this button. Okay, if I click on that, I said that this is a predefined slot. So if you click on that, we will see this slot will be run. First of all, I check if the title of the command link button browse is cancel then it means that it should be a stop. Ignore this part for the moment, and then we will come back to this. At first, it's not cancel. At first, it's browse, okay? So this will not be, the condition will not be true, and it will come to here. This is a method, this is an object, a method of this Q file dialog that will open a dialog for you, and it will show, based on the input parameter that we define, only the directories. And I asked, it will let us choose one directory. So, and the title of this file dialog would be open directory. And the location that it will show us, it would be the home directory. And I'm saying that only shows the directory. It can be files, it can be any other thing. Then I will check if dir is not empty. So because the dialog can be open and the user may not choose anything, just press cancel or close the dialog. In that case, we should not write this one. We should check first if it is empty or not. If it is not empty, it means that the user has chosen something, has selected something. Then I will create a QDIR directory with this directory. From that directory, I get a list of the file, text file, because here I'm defining that first it should be of type file. With this extension, it should give me QString list. So when text files will be QString lists. I have mtable model. As you remember, when we creating our main window, we said that we will use table view, and they will the view models are model-based objects. What does it mean? For every of them, we will have another variable which is of type a model. This is QS standard item model, mtable model. Okay. So with this one, at first I clear that one. It will contain the items of our table. Okay, first I will clear that, so it means that I'm clearing the table, and then set the status bar of the UI to loading files. It will show a message, show message. This is a predefined method in a status bar. Okay, it will show something here. The message is loading files. Then I will change the name of this one, UI.command link, this one, to cancel. Why? Because I want to be able to cancel loading the file. If it is a long process, we are going to use a thread for that. But sometimes I want to close my application. I change my mind. I don't want to load it. I want to cancel that. In that case, I'm giving this functionality to my command link button to be able to cancel that if it is running a thread, if it is loading the files. Then I will set the visibility of mProgress bar to true. You will see this in the next lesson because we don't have the time to discuss about this. And then I will disable this view because I don't want to let the user to click while I'm loading that. I don't want to let the user click on the table view, but I didn't disable the other things. Then I will call this thread to run, to load my files. To load these files, we will have this one. We don't have to discuss about things. I will just show you the run of your program to give you some idea what is happening with this example. I will also share this example with you later after the class. So here because it was debug, let's press Ctrl F5, browse. What was the path to GUI? This is the folder that I put some files, empty files. Just I wanted to show you how can you work with that. And I select this one. I put also some, if you look at this, I put some milliseconds, I mean some sleep time here to show you how the thread is working. But as you can see, while the thread is working, I can press second window and it will open the second window for me. And I can also work this with this one. So this is what I mean, what you have seen here, it has been done with the worker thread. But what is, I mean, the thread was responding to this one was the main thread. So because of that, I didn't have any problem. But if you have, if you do it with your main thread, if you don't create any thread, you cannot press on second window, because when you press browse, your main window will try to load your application, I mean load your files, and it cannot respond to any other things because it is busy with other things. It is busy with loading the file. But if you use a thread, then your main thread is not busy and it can respond to other things, which was for our case here, it was to respond to second window. If you have any question, you can ask. If not, we can continue. I mean, we stop the lesson and we will continue talking about threads in the next lesson. I will also answer your questions. For the people whose email was here, I just want to just this one. You have this one in your teams, and what you need to do is to add options. No, not this one. I cannot find it now, but in your teams, in the first lesson, I sent you some screenshot of that. I know you have class probably. For the people who want to leave, they can. But for people who want to have an answer for their emails, and if they have any problem, yeah, this is the path that you should add. This path is the path that you install your Qt. So you should add this path to here and this, to here, and then the version name will be written automatically. So this is your question. And another question. Yeah, for this one, you can use as one of your friends said, you can use this one. Apparently, you are using different version of Qt. You can use this one to create a Qt widget application. And don't say that I stuck somewhere, because you are supposed to be a programmer, and as a programmer, I may not be able with you for your next job, and so you should be able to find your to answer to these questions, and that's why I didn't reply to you when you sent your question. I wanted to let you work with your and try to, let you find your solution yourself. I hope you have done it yourself. Okay, it's I think our class is over, and you can.
I still had a question in my mail regarding what we should do if you add extra things in the file names or in the files themselves.
Ah, okay. Which one? Can I?
Yes,
this
that's it, and then it's on the bottom, last.
Okay, yeah. Do you have a class, or do you have time, 5 minutes to discuss about this?
The biomedical engineers do, because our class was cancelled, but I don't know for the electronics engineers.
Can any electrical engineering respond to me? Do you have time for 5 minutes?
Yes, I believe we do.
Okay. So very good. Thank you, Ariana, to remind me. I wanted to be very fast, and that's why I forgot this one. So let me read your question again for one of the last other important. I have an addition yet here. In the project definition, there is written that you can add new rows to the files and new parts to the file names, and that our software should be able to extract them without changing the source code. If we cannot change the source code, does this mean we should just ignore the added parts? No. Or should we something with those parts, in which case what? Okay, can anyone guess? I prefer to have some guess before giving you the solution. Suggest any solution for this one. No, guess, no.
What I would do is, well, since it's not known what the info is about, I would not process it, but just make sure that the program can handle it without crashing.
Okay, but imagine we are going to add a new row. Have you seen any program that has a configuration file next to your project and you have to change that configuration? Probably you have seen that. But in some projects, it's like that. You have, for example, okay. Did you see, for example, even when you are working with your home, yeah, like here. Okay, this is an internet-based application, but a Windows-based application which is not connected to the internet. You may have a setting menu in your application. I'm not asking you to have a setting menu. It's something, a new feature that you can add. Okay, that would be great, but it's not compulsory for you to do that. But those setting buttons are connected to another file in your hard disk. Or if it is an internet-based application, it is connected to your account on the internet, okay? So using those setting buttons, you can change the behavior of your application. So even if you didn't write any code for your program, but it is dynamically your program can dynamically be changed. You don't need to build your program again. You'd have that exe file and you can change the setting of that application. And if you change the setting of the application, it will work differently. So in your case, you have some files, and inside those files, there are some properties. But you don't know those properties. You know that the structure is like that. Okay, we have some numbers, or we have some, I think it was numbers and some values. But you don't know how many items it should have. You don't know which one is which one. So you will have a text file like this. Let me see project definition. I cannot exactly remember what was. Yeah. Okay, it was the structure was like this: a number and a value. Okay, the best practice is that these numbers are just some unique, should be a unique. It's not the best way, but okay. For your application, for the simplicity, we consider that we have an enum, which this code, but those enums should have a name. Okay, those names are what? They are, for example, the age, speed, and some other things. But we said that we can have some other objects here. What can we do? We can have a configuration file like this one next to our project, next to our exe file. Usually it's not next to our exe file. It's somewhere on the internet that the user cannot change it. But for this project, it's okay. I just wanted to let you be familiar with the concepts of dynamic programming, to know you should not hard code your implementation. What can we do? We can write, for example, speed yeah, age, height, name, and so on. Okay. Then when you are reading your file, you will open this configuration file. And if you see a speed, you know that the first thing that you read from here is a speed. At least the title, it's saying to you that the title is a speed. Okay. The title of the first property is speed. The title of second property is age. The title of the third property is height. Okay. But here, as you can see, we have 8, but we do not have the rest. We only have these 4. It's not really good. That's the mistake for the user. The user should write a name for all of them. You can show a message to the user that you don't have your configuration file has some missing arguments, but again, we should not crash. We should be able to read the rest. We read the rest, but we say that, for example, missing name. But how can we store them? Because I saw some of you, like here in the human.h, we have different members for that. But I gave you some feedback during your first round of your project. I told you this is not really good. Okay, it is good for file names because we can access them. For the members that we access them, we work with them regularly, it's good to have a separate variable for them. Okay, but if not, if we have many properties here, and it's better to keep all of them in one container. For example, the container here, just an example, depending on your usage, it might be different. For example, it would be map of your enum. This is just, I didn't include map, that's why it's, it gives us some error. Your enum class, this is just a pseudocode. Enum type, I don't know. You define an enum type and the CD string. And that would be your all data. Okay, this is just one way. Instead of a CD string, you can have, for example, a new class here, your custom class. Why you have a custom class? Because probably you are working with those, your properties have some meaning for you. But from your projects, I remember you didn't get what an object is. We have time in the next lesson to talk more about the objects. But for this one, to sum up what I said, you will have a configuration file. Inside the configuration file, you will have the title of your properties. In your files, as we saw here, you have some items like this. You know that the first one belongs to the first one. The second one belongs to the second one. And if we add a new item, we will add a new item here. We add a name for that. Even if we don't add a name for this one, you should be able to read this because you know that every row of this one is an item and you save it in a container. You don't have to have a new variable for that. The problem for you, the problem came from this thing for you because you always think that you should have for every property, you should have different variables, but you don't. You will have a container of the properties. So you can read your file and fill that container. But then you have to deal with that. For example, for some files, we may not have name. Not name. So for some files, we may have 4 properties. For some other files, we may have 5. But the problem with what is the problem with select? If we do not know the name of that, then we cannot have a select for that. So it's the way that you can solve it. I mean, you should think about these things. If I can give you the solution for the other ambiguities that may come up, but I think till now I got you a lot. So I think the others you should do it yourself. Is it okay? If you didn't get that, ask me, because I really like to see good implementation for your final project.
I have another question.
Okay.
When will we get the grades for the first part?
Only Adrian told me only when you can have all the grades after. When we are after you present your final project. So he told me that we cannot share the scores now with you as it's illegal. So. But don't worry, all of you. I mean, the minimum score that you have is 5 out of 10, and but most of you had very good scores, and you should not be worried. But just keep in mind the feedbacks I gave to you, and also the feedbacks I'm giving to you now during these today lessons and next lesson. Next lesson, we don't have many things to say. We only have threads, and then we only talk about the projects and the object-oriented programming. Do you have any question? Did you get really this part or not? Ariana, did you get what you asked?
Yes, I got it. I think I just need to look at it again to really see how I will implement it.
Okay, very good, very good. Okay, if there is not any other question, we can stop the lesson. No? Okay, have a nice day, everybody.
Bye.
Bye. Bye.